Okay, here we're going to look at graphing three different types of equations. Okay, we're used to graphing equations of the form y equals mx plus b. Okay, remember y equals mx plus b. Okay, those are linear equations, okay, with the slope m and y-intercept of b. So now we're going to look at, are these three different equations here? Notice they each start with y equals. Okay, but there's an x and a 2 in each of them, but they're in different places. And where the x and the 2 are makes a big difference in what's happening in your table graph and the relationship between x and y. So we've already done a graph like y equals 2x and a table for y equals 2x. And we should notice that that is in y equals mx plus b form. Here the slope is 2, and the y-intercept technically is plus 0 there. Okay, and we've already done this. And what you do is you take your x value, and I made these tables from -3 to +3 for each of these, just to keep it consistent. If you substitute -3 in for x, you would do 2 times -3, which gives you -6. Substitute -2 in, 2 times -2 will give you -4, and so on. -2, 0, 2, 4, 6. Okay, so if you need to pause the video and actually go through and do that on your own, feel free to do that. Okay, and then what we'll do is we'll graph the equation on the grid below. So the first one we'll put on the first grid. And you need to make your own grids. And remember how we looked at where do we put our grid or where do we put our axes? Well, we have negative and positive for x and y. And notice we get negative and positive values for y. So we get negative values for x, we get negative values for y, and positive for x and y. So that means we'll put our axes kind of in the center of the grid. Okay, so we'll draw our axes there. Okay, and then you'll plot the points on that grid. Okay, and that's something that I'm going to put the answer key up here in a minute, but you can actually go through and do that. So for the sake of time, okay, you can go through and do that on your own, and then I'll have the answers up here in a minute. For the second table, we have y equals x squared. So now when you look at that, now this is a little bit different. When you look at squaring something, it means multiply by itself. So now you're going to take your input, in this case -3, squared, and remember that means -3 times -3, which is +9. Okay, if you substitute -2 in, I'm not going to write these steps down all in each of them, but -2 squared would mean -2 times -2, which is a +4. Okay, so go through and you complete that table, and then we'll look at the grid in a minute. And then in the third table, okay, and you're going to pay attention to whether or not you have positives or negatives, and that'll tell you where to put the axes. And then in the third table, with y equals 2 to the x, okay, this is a little bit trickier. Okay, so we're going to use our calculator on this one, and we're going to express our answers as fractions if fractions show up. Okay, so when we put -3 in, we're going to do 2 and then exponent -3. I'll show you on both calculators. On the graphing calculator, if you do 2, the exponent key is the caret button here. Okay, right above the division symbol, there's a caret, that's exponent, and then put -3 in. Press enter, and it gives me 0.125. Now we're going to make that into a fraction by pressing math, and then the first option there says arrow frac. That'll turn our answer into a fraction if it can, and that gives us 1/8. Okay, so 2 to the -3 gives us 1/8. On the Texas Instruments the TI-30XS calculator, okay, you can do the same thing. If you do 2, and then the exponent key again, and then put -3 in. Now notice right now I'm in math type, and I'll show you the other mode in a second. Okay, right now I'm in math type. Do 2 to the -3, and it actually gives me 1/8 for the answer. Okay, now if you're in a different mode, if you press mode and go down to math, go down and highlight math print, okay, that's what I was just in. If your mode is in classic mode, if you do 2 and then exponent, now notice it doesn't move the cursor up to the exponent. You put -3 in like that, and there it'll give me the decimal 0.125. To make that decimal into a fraction, there's an F arrow D button here in green. So if I press second, F arrow D, it'll turn my fraction into a decimal. Okay, so those are the two ways to use your calculator to evaluate those exponents. Okay, I'm not going to go through every single one. Okay, but when you are all done with the table, and again, this is why I suggest you pause and go back and complete each of these two tables. But for the sake of time, pause the video, and I'm going to put the answer key up here. Okay, so here's the answer key for each of the tables. You'll notice that for y equals x squared, we get positive answers for each of them. And notice we get the same y value. When x is negative 3 and x is positive 3, we get the same y value of 9, because negative times negative is positive, and positive times positive is positive. Okay, in the table for y equals 2 to the x, okay, notice we get 1/8, 1/4, 1/2, 1, 2, 4, 8. Okay, so all the answers there are positive. Now 1/8 is very small, but it's still positive. Okay, so the significance of that is when you make the table of values, the x squared, okay, so for y equals x squared, we have all positive numbers, so that means we'll put our axes in the center for the, so x can straddle the center there vertically, and then we can put our x-axis near the bottom, meaning we're going to have positive y values showing up on our graph. Okay, same thing for the y equals 2 to the x. X goes from negative 3 to 3. So we're going to put the y-axis kind of right in the center there. And the x-axis we'll put close to the bottom because we don't need any negative y values. Okay, so that's where we'll put our axes for those last two equations. Okay, now when you go through and plot the points, so negative 3, 9. So we'll use a scale of 1. There's negative 1, 2, 3, and then up 9. Okay, so we have a point right about here. And then negative 2, 4, we can plot that. Okay, and so on. Okay, when everything is said and done with the y equals x squared, you'll end up with a U-shaped graph. Okay, that's the one in the middle. And then when you plot the y equals 2 to the x, you'll end up with this curve here. Okay, so right here is the point negative 3, comma 1/8. This will be negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and so on. Okay, so you can see that even though each of these equations has a 2 and an x in them, you get very different tables and graphs when you actually evaluate those relationships. Okay, the first one we can say is linear. Okay, that's definitely linear. It's a line. Okay, for the U shape, this is not something I expect you to know right now, but that's a parabola. Oops, parabola. Of course, I spelled it wrong. Parabola. And then the third one is actually called an exponential. Okay, that's an exponential graph. Okay, exponential because x is the exponent. Okay, so what we focus on next, okay, after you plot all those and graph them and see how different they are. Okay, what we're going to look at next is how would you explain the arithmetic involved with each expression. So for y equals 2 to the x, so think about how do you get your answer for y. Well, we're given x value, so x is the input, and how do you get the answer for y? Well, to get y, okay, the output, we multiply x, which is the input, by 2. Okay, that's a pretty simple one. So to get y, so to get the output, we multiply x, okay, the input, by 2. Okay, and again, if you put, say, 1 in, you would do 2 times 1 to get 2. If you put in 2, you do 2 times 2 to get 4. Put in 3, you do 2 times 3 to get 6. So you multiply the input x by 2, and that gives you y. For the y equals x squared, so for y equals x squared, to get y, okay, or to get the output, we do what? Well, when you put a number in for x, like say 3 3 squared means you multiply it by itself. You multiply the input by itself. Okay, so we multiply x, or the input, by itself. Now I will clarify there that we're multiplying it by itself just one time. Okay, because it's squared, so you multiply by itself once. Okay, so 3 squared would be 3 times 3. If that exponent was something else, like a 4, like 3 to the 4th, then you would do 3 times 3 times 3 times 3. So whatever the exponent is, tells you how many times you're going to multiply the number x, or the input, by itself. Okay, for y equals 2 to the x, to get the output, or to get y. Okay, this is a little bit trickier. Okay, what do? Well, think about in your table of values. Okay, I'll go fill them up in here. 8, 4, 2, 1, 1/2, 1/4. Oops. Okay, it's easier if you look at the 0, 1, 2, 3 for x. Well, with the 1, if you look at 2 to the first, that's 2. 2 to the second is 4. 2 to the third is 8. Well, here, the inputs are the x values. Those are what's changing, like 0, 1, 2, 3. So in order to get the output, you multiply 2 by itself, whatever the input number of times was. Okay, and that's a little bit trickier. Okay, so we multiply 2 by itself x times. And that is not as obvious with the negative numbers or the 0 for x. Okay, but if you think about the positive exponents here, that's the easiest way to look at it and see what's going on. If you had a 4 there, then you would multiply this output by 2 again. So that would give you a 16. And that would be 2 times 2 times 2 times 2. So you multiply 2 by itself 4 times. So again, to get y, you multiply 2, the input, by itself, x number of times. Okay, so moving along to the next page. So using those three relationships, okay, number 11, evaluate each expression when x equals -2. Okay, so for 3x, you're just going to multiply 3 by the input of -2. So 3 times -2 gives you -6. Okay, so there's an easy one. For x squared, you're doing -2 squared, which means, remember, -2 times -2, which is +4. Now in your calculator, make sure you put parentheses around -2 and you won't miss it. Okay, some calculators will do it correctly no matter what, but just to avoid making that mistake, when you substitute a value in for a variable, if you put parentheses around it, you won't miss it. For x cubed, remember that means -2 cubed, which means -2 times itself 3 times. So that'll be +4 times -2, which is -8. X minus 1 squared, you're going to do -2 minus 1. That's in parentheses, so order of operation says you do -2 minus 1 first. So -3 squared. Now we're back to the idea of x squared. So that means -3 times itself, which is +9. Okay, and the next one, when x equals 3 now. Okay, so if x equals 3, you're going to do 3 squared. You get 9. Okay, so I suggest you look at doing these on your own, and I suggest you pause the video, and I'll put the answer key up here for you. Okay, so there's the answers for that part. X to the 4th means you're going to substitute 3 in. You're going to multiply 3 by itself 4 times. Okay, so 3 times 3 is 9, times another 3 is 27, times the 4th 3 will give you 81. Okay, moving along to part C. Now we're going to look at negative exponents. Okay, and these are trickier to look at, so we're going to use our calculator. So to evaluate 3 to the -1, if you put that in your calculator, 3 to the -1, Okay, I'll use the graphing calculator here. I showed you earlier how to evaluate with the other calculator. Okay, so 3 to the negative 1 gives you 0.3 repeating. So as a fraction, math, enter, enter. Okay, or in the TI-30, make sure you use the math pipe, and it'll give you 1/3. Okay, so that'll be 1 over 3. 3 to the negative 2, so if you enter that in, 3 and then exponent negative 2 gives you 0.1 repeating. Math, enter, enter, gives you 1/9. Okay, if you did 3 to the negative 3, it'll give you, when you do it, it'll give you 1/27. And then 3 to the negative 4, that'll give you 1 over 81. Okay, and that's just using the calculator. So if we look at in part D, make a conjecture to explain how to evaluate an expression with a negative exponent. Well, if we look at what's happening, if you were to ignore the negative exponent, so 3 to the negative 1, if that was 3 to the first, that's 3. If you look at 3 to the negative 2, if you ignore the negative exponent, 3 squared is 9. 3 to the third means 3 times 3 times 3, which is 27. 3 to the fourth, again ignoring the negative exponent, is 81. Okay, so when you look at these answers compared to when we had a negative exponent, what's the difference? Well, notice that each of these answers, like 1/3 and 3, are the reciprocal of each other. 1/9 is the reciprocal of 9. 1 over 27 is the reciprocal of 27, and 1 over 81 is the reciprocal of 81. Remember that reciprocal is a fancy way of saying flipped. Okay, so 3, remember you can write that as 3 over 1. If you flip that, take the reciprocal, you get 1/3. 9, remember, is like 9 over 1. Take the reciprocal, or flip it, you get 1/9. Okay, so the negative exponent, you treat it as a positive exponent, but then take the reciprocal. Okay, so there's a lot of ways to explain this, but you can evaluate, one way to write it, you can evaluate as a positive exponent, then take the reciprocal. Okay, and remember, reciprocal is just saying flip it. Okay, put a 1 on top, flip it, okay, however you want to think about it. So if you have variables now with negative exponent, okay, we already said that if you had, say 3 to the negative 3, we already said that was 1 over 27. So now if you're left with a variable like x to the negative 3, well, now we would just look at it as 1 over x to the positive 3. Okay, so you would do x to the third and then flip it. Okay, so that would be 1 over x to the third. X to the negative 2, well, evaluate it as a positive exponent, x squared, flip it to get 1 over x squared. X to the negative 1, x to the first as a positive exponent, and then flip it. So 1 over x to the first, or just 1 over x. You can write it that way. Now, 2x to the negative 1. Well, now you be a little bit careful, because the negative 1 is only with the x, it's not with the 2. So now, you would take the reciprocal of x to the first, and remember, that would be 2 times 1 over x. Again, it's because the negative 1 is not with the 2, it's with just the x. So now if you do 2 times 1 over x, that would give you 2 over x, because that's like 2 over 1. And when you multiply fractions, you go straight across. 2 times 1 is 2. 1 times x is x. For negative 5 times x to the negative 2, same idea, only the negative 2 is with the x. Okay, so the exponent is only on the x. So it's negative 5 times 1 over x squared. So treat that as negative 5 over 1. So that would be negative 5 over x squared. Okay, now if we look at 2x to the negative 1, and just suppose that 2x was in parentheses like this, then the negative 1 is with both terms. So what you would do is you would take whatever's being raised to the exponent. Now 2x is being raised to the exponent. So raise it to the positive exponent. So that'd be 2x all to the first, or just 2x. And then the negative exponent, the negative, we'll flip that to get 1 over 2x. Okay, if you had, say, 2x in parentheses to the negative 3, well, then what you would do is that 2x is all being raised to the third. So you would do 2x to the third, and we can evaluate that. We can simplify it a little more, and then flip it. Okay, so we'll put a 1 on top. Well, 2x to the third means 2x times 2x times 2x. And I'll write that step out. 2x times 2x, oops, times 2x. 2 times 2 times 2 is 8. And then x times x will be x to the third. Okay, so you can see if there's parentheses around the 2x, that's much different than with the without the parentheses. Okay, so that's just something you got to be careful of. Okay, so that's evaluating these different expressions with exponents and how you deal with that. The very last page here is looking at graphing these different equations. And I'll remind you that we already graphed the parent functions of these. So what I mean by that, we already graphed y equals x squared, and we graphed that from negative 3 to 3. Okay, that's what this middle one was here. And notice we got the parabola, this U shape. Okay, so that's if you just graphed y equals x squared. Okay, so looking at this graph. Well, now what we're doing is we're taking x squared minus 8. Well, the only difference is we're taking these answers now and subtracting 8 from them. So we're taking the y equals x squared, getting an answer for that, and then subtracting 8. So what that'll do is that'll take 8 off of each of your answers here for y. So if you subtract 8 from each of these answers, what that's going to do is shift your graph down 8. So it's going to be this shape shifted down 8. So this first point here that we had graphed, negative 3, 9, should shift down 8. 1, 2, 3, 4, 5, 6, 7, 8. So we should end up with a point at negative 3, 1. Well, let's see what happens when you actually evaluate that. Okay, we're going to do a table of values from negative 3 to 1, and I have the table already made here. Okay, so again, this is for the sake of time. Okay, what I want you to do, make that table here from negative 3 to positive 3 for x, and go through and actually evaluate that. Put negative 3 in. Negative 3 squared, again, will be positive 9. Subtract 8 will give you positive 1. Okay, you can plot that point, then plug in negative 2. Negative 2 squared will give you positive 4. Subtract 8 will give you negative 4. Okay, notice that when you go through that whole table, each of these y answers will be 8 less than they were before. Okay, so you can go through and do that. And again, I'm going to skip ahead here just for a minute just to explain a few other things. You're going to graph y equals negative x squared on that same, I'm covering up answers here so you can't cheat real fast. You're going to do negative x squared, so when you substitute numbers in, when you substitute negative 3 in, you're going to do a negative 3 squared. Okay, well, a negative 3 squared like this, negative 3 squared is 9.